In the previous exercise, we filtered the ratings data coming from the data generator. Now I want to enrich that data with the customer entities, with that customer table. To do that, first we're going to have to set up that customer topic that we're getting from the external MySQL database. We have to set that up as a table. We have to tell ksqlDB that it's a table. And after that, we'll be able to do the join. The join falls into place right away. Let's check it out. To create a new table, first we create a stream over the Kafka topic the way we did before. That should look familiar by now. Then we're going to create a table based on the stream. I want to set the offset to earliest so that we are sure to process all the records. This table is built as an aggregation of the stream using the latest by offset aggregation that you see in the query there. With the table built, we can now use it to enrich the ratings stream that we've already got. We use a stream table join on the common key of user ID that both the stream and the table have. Obviously, that's important. You can't do a join in a relational database without a common foreign key, so you need that same kind of thing here. Also, as an aside, when I had you create these topics, I said, hey, make sure they both have 6 partitions. That matters as well. We want these topics to be co-partitioned, same key, same number of partitions, and everything works out well if we do that. So first, prototype the join with just a select, make sure that it works and returns the results that we're expecting, and basically looks reasonable, which it does. Each rating now includes information about the customer, which is cool. So we'll persist this to a new stream by prepending create stream to it. The result of a stream table join is a stream. And now this is a persistent query, creating a new Kafka topic with the records, just like we did in the last exercise. Note that we're overriding the default Kafka topic name to a hard-coded value. If we don't do this, the topic takes the name from the stream plus an internal identifier prefix, and it gets a little messy, and we need this topic later on. So let's check that the new stream works. It looks good, a live stream of event, and as each event arrives, the customer information gets added to it. So looking at the live ratings stream for a particular user, how do we do that? So note their current club status, bronze. Imagine the customer status changes. It's not changed in Kafka, it's changed in the system in which the customer data is created, the database, right? That MySQL database out there in the wilds of the internet. Probably changed by an application, not a manual SQL update statement in practice, but work with me here. And notice how the next rating that comes in reflects the latest club status for the particular user. A minute ago, the event happened and it was joined to a bronze status, and now it's an upgraded status, and that event is happening now and being joined to the current state of that customer in that table. ksqlDB has a data flow view, which is super cool. But if you want broader context, including where the data comes from and goes to, you want to use the data lineage view. And as we start to create a more interesting pipeline, that data lineage view becomes more and more useful. So we made a table, we joined a stream to a table, absolutely fundamental activity in data pipelines, and now you've done it.